Hello and welcome in. Mark here, aka the Markster. This is video number 24 in the FreeCAD series. Today we're going to examine some of the tools in the part workbench that we haven't really looked at yet, or not very completely anyway. In particular, the defeaturing tool here. We'll use this advanced utility to create shapes, and the 3D offset utility. Let me show you which version of FreeCAD we're using. 0.19, revision number 19694, and I'm on Windows 10. Currently the latest stable release is 0.18. This is the development version. So we are in the 0.19 development cycle. When it is deemed ready for release, it will become the new stable, and we'll begin the 0.20 development cycle, and I'll download it and I'll start using it. Well, why not use the stable version? It's more stable. Well, it's a little bit of a misnomer. In this context, stable refers to stable as in not many changes are being made to the source code for version 0.18. Only a few bugs fixes are getting backported to 0.18. So very few new features will come into 0.18, the stable release. New features all come in to 0.19. It's not stable, it's changing a lot. It doesn't mean 0.18 is more crash proof than 0.19. It means it's stable from the standpoint that it's not changing a lot. There are actually bug fixes that go into 0.19 that correct crashes that do not get backported to 0.18. But there's also new code in 0.19 that can result in crashes too. Anytime you add new code to the software, you're running the risk of creating new bugs. Even a new bug fix can create other bugs. So the last thing you want is your stable release crashing on people. So, it's a very conservative approach as far as backporting bug fixes. Plus, it's just more work. So anyway, that's my take on it. What you're looking at here is a file that I've downloaded, a step file, and it's just a part. I thought, well, this is something I can use in a video to show this defeaturing tool and some of these other tools that we'll get to. So whenever you import a file that was not created in FreeCAD, you end up without any history. You just have the one object. So we don't have the history of how this object was created. We don't have the polar array, presumably, that was used, or sketches, or whatever it was that was used. So it makes it more difficult, because let's imagine that what we want here is a 5-hole pattern. Everything else is perfect, except we need a 5-hole pattern. So that's what we're going to do today. We're going to remove these 8 holes and add a 5-hole pattern. So to use a defeaturing tool, we select the internal faces of the holes to remove. This one has 2 faces per hole. I don't know if that's a feature of the step files or the CAD software that was used to create this gives you two faces for each cylinder, because notice the outside here, there's a seam line here and another one here. So FreeCAD, you only get one seam line per cylinder. This one you get two, which I like that because those seam lines can come in very handy. So anyway, let's use this defeaturing tool, and that gets rid of those holes. Now it can also be used to remove not just holes but features that are sticking out of something. Let's see what that'll do, just as an experiment. Yeah, I don't want to do that though, I'm just showing you as an example. Alright, so now we need to create our 5-hole pattern, and we could do this all kinds of ways. We could add another cylinder into there and make it the same size, but I want to show you this advanced utility to create shapes. And we're going to create a wire from edges, and I'll select these two edges, and I'll select planar and create a wire. So now we have a wire to work with, and we can extrude that wire, and we'll do it symmetrically. We'll create a solid. Symmetrically, it pokes out of both sides, so we extruded 10 millimeters from the wire here, from there, in both directions. It's okay if it sticks out. It's even better if it does, because sometimes when you cut, if your faces are even right here, if they were coplanar, it's kind of rare, but it can occasionally cause a problem with the cut. You'll end up with a little bit of skin left. So now we need to create a 5-hole array, a polar array, 5-cylinder array. We can do that in draft. Select our extrude object, click the array, and by default it's an ortho array, and what we want today is a polar, and we want 5 polars for our 5-hole array, exactly like that, except we're on the wrong axis. By default it goes along the z-axis, so we need to use the y-axis instead, and that's no problem. We just find our axis property here, set z to 0 and y to 1, and now we're in good shape. So we can select the defeatured object as the base, the array as the cutting tool, and do a cut. Now we have our 5-hole pattern. Now let's check our geometry, and it looks good. No errors. Alright. So now that we've covered those first two things that I wanted to show you, we did this, we did some work with this in a previous video. The only thing I don't like about it is it's non-parametric, which also the defeatured tool is also non-parametric. So if we look at our dependency graph here, we see that this object here, the part feature, 525124. This one is nonparametric. There's nothing connected to it. The defeatured object is not connected to its parent object. The cut object is dependent upon the defeatured object because it was cut from the array. The wire is nonparametric. It is not connected to the defeatured object. Extrude depends on the wire. The array depends on the extrude, and the cut depends on the defeatured and the array, because defeatured was the base and the array was the cutting tool. By the way, if you're not familiar with that dependency graph, it requires a third-party software called GraphViz. You must install that to use it. It'll come in very handy troubleshooting your CAD files once in a while, your models. Okay, so now let's find a reason to use this utility to offset in 3D. Let's imagine that we want to create a spline that will be able to go into here, fit into here. So we can make that with a cylinder. And we'll rotate this 90 degrees. I'm going to double click on it and use the dragger tool. When I first started using FreeCAD, I would double click on things here and this thing would come up and I had no idea what it was, and it really aggravated me until I figured out what it was. And then I said, wow, what a great tool this actually is for moving things around on the screen. That's my story. I'm sticking to it. Alright. So I think I'll just come out a little bit further. And we'll fine tune in the placement property here. 5 is too much. 4.25. That's good. I don't want it all the way out or even either. Alright, and now we'll make our cylinder a little bit bigger. Radius. 4mm radius. And now we'll cut the cylinder with the cut to create our little spline object. So this will be able to poke right in to this cut object. It should mate right in there. Okay, so that's all fine and dandy, but it's not going to go in because it's the same size. You need a little bit of clearance. You might be able to press it in with a shop press or a vise or something, but we want something that we can just push in easily by hand with just a little bit of clearance. So let me show you the cross section. I'm going to create a fusion object just temporarily. And let's have a look on the clipping plane. We want the y-axis here. Why am I not seeing the I'm not seeing the little gear things. Maybe because they're meshed all together. I don't know. Anyway, let's go ahead and use that 3D offset tool, and then we'll try it again and see if we can get a better look at it. Maybe I'm using the wrong thing here. I don't know what's going on there. Let's see. Hide this one for now. Select this object. Use our 3D offset tool. It's very similar dialog to the 2D offset. I don't want arc. I want intersection and intersection. And I want it smaller, not bigger, so I'm going to put a negative value here. Minus 0.05 millimeters. This might not be an appropriate clearance value, it might be not enough, maybe too much. I'm not really sure. Now, let's fuse these two together and have a look at the cross section. See how well made it is. We use our Crosscut tool right here. This one. Create a cross section. Put it on the XZ plane. And we can adjust the position here. Let's see if that's going to catch those gears and see. Hide it. Oh yeah. Now we're looking good. Let's look at it from the front. Dead on. Where you at? Zoom in. So now let's see what we're looking at here. Yeah, this is the original. And this is our offset, which is a little bit smaller. Let me take a cross section also of just this part so we can compare the two. This is a useful tool for examining these fits. I'll take one right there. Now let's hide this object. And we'll look at it from the rear here. Zoom in. So that is the original size. And this bit here, there we are. The yellow is the original. So we have just a little bit of clearance there. We can check it with the measuring tool. 60.7 micrometers. And that's at this angle here. See, toggle 3D. There we are. Where we at? 65. .3D because we've got some distance between them. And clear all, close. You can hide these two. the offset is the part that we'd want to use. And the cut, these two should fit together pretty well. Let me transform this in the Y direction just a little bit. Let's look at it in wireframe mode, see what that looks like. It's another way to get a kind of a view inside. Yeah, that works even better than the Crosscut. So we see our cut object, and over here we click the offset. And if you want to compare it to the original, they were the same. So we had no clearance at all. And now we have a little bit of clearance, and we could adjust this if you wanted to. 0.01 maybe. Sometimes you have to delete some of these numbers before it lets you add more to it. But now it's even tighter clearance. Okay, well, I think I've covered what I wanted to cover today in this video. We looked at the defeaturing tool. Mostly it's useful for when you imported a file and you don't have the history. If we had the history, we would simply have gone in and changed this array to 5 instead of 8. But there could be times when you created an object in FreeCAD, and let's say we needed a 5-hole pattern, but we only need it for holes. In which case we could remove the extra hole with the defeaturing tool. It would be nonparametric, but that would be a way to do it. I would prefer instead to use the explode tool, which we used before here on the array, and do it that way. And let you get at the individual items in the array. I covered that in an earlier video, so you should be watching these in sequence in the order they came out. I know some of them are kind of long, and I'm kind of talk kind of slow, but I think you'll find it worthwhile to do it. So that's going to be it for today. Thank you for watching, and as always, have a great day.